Dear students, welcome to the video permutations of R objects from N objects. So far we have been dealing with permutations in which all of the objects were selected and arranged. Now we are going to see cases in which some of the objects are going to be selected and make some permutations. In these cases we call it permutations of R objects from N objects. First, I'm going to give you a definition and notation used to deal with these types of questions, which is called NPR. Now consider the case you have 5 letters and you are going to choose 3 letters out of these 5 letters. These 5 letters. Now, as we are going to make actually a 3-letter word, so we have 3 positions here. Now, for the first position, we have 5 options. We have 5 options to choose. So for the first position, we have 5 options. Now, one of these 5 letters is selected, so we have 4 options left. And for the third position, you have 3 letters left to be selected to put here. So overall, it will be 5 times 4 times 3, which is 60. Now, when you are going to have a permutation of R objects from N objects, it is denoted by N P R. N is the total number of objects and R is the number which are going to be selected. So, and the definition of NPR, you have the key in your calculators, you can easily calculate without knowing the formula and definition. You can enter N and R in your calculator and it will give you the number. But NPR means N factorial over N minus R factorial. For example, in this case, you are going to select 3 out of 5. So 5 is N, 5 P, 3. So it is 5 factorial over 5 minus 3 factorial, which is 5 factorial over 2 factorial. 5 factorial is 5 times 4 times 3 times 2 factorial over 2 factorial. They cancel out each other. Again, it will give you 60. You can have these 2 methods in your mind to use to deal with these types of questions. First example, in how many ways you can be 5 playing cards from a standard deck of 52 cards be arranged in a row. So you have overall 52 cards, of which 5 are going to be selected. So it would be N is 52, P, R is 5, which is N factorial, which is 52 factorial over 52 minus 5 factorial, which gives you 47 factorial. At the end, your answer will be 3, 11, 8, 7, 5, 200 ways. It is the final answer for this question. Second example, in how many ways can 4 out of 18 girls sit on a 4th-seat sofa when the oldest girl must be given one of the seats? Now, as the oldest one is going to be given a seat, so we have just 4 seats, 3 seats available for the rest of the girls. So out of these 18 girls, one of them is would be the oldest one, so 17 girls are going to be the options from whom you are going to choose 3. So it will be 17 P3. because the oldest one definitely will be given a seat, so you have 17 girls left, and one seat will be taken, occupied by the oldest girl, so 3 seats will be available for these 17 girls. But the oldest one doesn't mention that a specific seat is going to be taken by the oldest girl. So this girl can choose one of these 4 seats. So she has 4 options to choose. So it is the number of seats that the oldest girl can choose, and 17p3 is the number of permutations for which 3 girls are chosen from 17 girls. So the answer will be 16,320. Example number 3, which is really common in Cambridge examinations. In how many ways can 4 boys and 3 girls stand in a row when no 2 girls are allowed to stand next to each other? Now we have 4 boys. I label it B1, B2, B3, and B4. So we know that you have 4 boys. These 4 in 4 factorial way can make permutations. They can change their places in 4 factorial ways. Now, but for the girls, as no 2 girls are going to stand next to each other, it means that between any 2 girls there should be at least 1 boy. Now we have 3 girls here. So the first girl, these are the position in which the girls can stand. Why? Because there should be at least 1 boy between any 2 girls. So for the first girl, we have 3 girls. For the first girl has 1, 2, 3, 4, 5 places available to stand. So it is the number of options for the first girl. Now let's go for the second girl. The second girl, so one of them is occupied. For example, G1 stands here. Then the second girl has 1, 2, 3, and 4 options available to stand. So one of them is occupied. Let, for example, G2 stand here. Now the third girl, she has 1, 2, 3 options to stand. So it will be 3. So it will be 4 factorial times 5 times 4 times 3. The answer will be 1440. Or in using the other notation, or using NPR, you can say that there are 4 boys, and out of these 4 boys, all of them are going to be selected, so it would be 4p4. But for the girls, as if there are 1, 2, 3, 4, 5 positions available, and 3 of them are going to be occupied, so it will be 5p3. At the end, it will give you the same answer.